On June 22, 2026, China's Ministry of Commerce published a routine-looking notice. 10 American companies had been added to an export control list. 2 names on that list mattered more than the other 8 combined: MP Materials and USA Rare Earth. If you don't recognize those names, here is what you need to know. These are the 2 companies the United States government has spent the last 3 years building, funding, and betting on to solve one specific problem: America's near-total dependence on China for the materials that go into almost every advanced weapon system it owns. And on June 22nd, Beijing didn't just criticize that effort. It reached out and touched the 2 companies sitting at the center of it. Most people who heard about this story filed it under trade war. Continued. Another round in a fight that's been running for years. But that reading misses the actual shape of what's happening, because this isn't really a story about tariffs or trade balances or even about China and America as rivals in the abstract. It's a story about where power actually sits inside a modern industrial supply chain, and it turns out that power doesn't sit where most people assume it does. For the next 20 minutes, I want to walk through how a handful of unpronounceable elements, the ones sitting in that awkward row at the bottom of your old high school periodic table, became the material basis of almost every fighter jet, missile, electric motor, and wind turbine on Earth. I want to show you how one country came to control the part of that supply chain that actually matters. And I want to look honestly at whether the current Western effort to break that control is actually working, or whether it's racing against a clock it's going to lose. Let's start with the word itself, because it's misleading, and the confusion it creates has shaped this entire debate. Rare earths are not rare. The 17 elements that make up this group, neodymium, dysprosium, terbium, and the rest, are, according to the U.S. Geological Survey, relatively abundant in the Earth's crust. You can find deposits of them in the United States, in Australia, in Vietnam, in Brazil, in Greenland, in dozens of places around the world. If the story were really about who has access to the raw ore, this wouldn't be a choke point at all. It would be a commodity market like 100 others. The actual bottleneck sits one step downstream. Rare earth elements never occur on their own. They're bound up together inside larger mineral deposits, chemically tangled with each other in ways that make them extremely difficult to separate, turning raw ore into a usable, high-purity metal, and then turning that metal into a finished magnet that can survive inside a jet engine or a missile guidance system requires a long, toxic, capital-intensive industrial process. Mining the ore is the easy part. Refining it is the part almost nobody else in the world knows how to do at scale. And that's the mechanism worth holding onto for the rest of this story. China's power here was never really about geology. China holds something like a third of the world's known reserves, a large share, but nowhere close to a monopoly. What China actually controls is roughly 90% of global processing capacity and nearly 90% of the world's rare earth magnet production. The choke point isn't the mine, it's the one refinery nobody else built. So how did that happen? Not by accident. And understanding the history here matters because it tells you something about how industrial power gets built in the first place, deliberately, over decades, while the other side wasn't paying attention. Until the late 1980s, the United States actually led the world in rare earth production. A mine in California's Mojave Desert, called Mountain Pass, supplied a majority of global demand for decades. Everything from color televisions to early guided missile systems ran on material pulled out of that pit. But through the 1980s and 90s, 2 things happened at once. Environmental regulation in the U.S. tightened, correctly, after federal investigators found the mine's operator had allowed hundreds of thousands of gallons of contaminated wastewater to leak into the desert over more than a decade. And at the exact same time, China began flooding the global market with rare earths priced far below what Mountain Pass could compete with, the kind of pricing only possible with heavy state subsidy and far looser environmental enforcement. By the late 1990s, Mountain Pass simply couldn't compete on cost. It shut down its separation operations in 1998 and closed almost entirely in 2002 after another waste spill. China's share of global production, meanwhile, climbed past 90%. This is often told today as the result of a single visionary decision, usually anchored to a quote attributed to the Chinese leader Deng Xiaoping in the early 1990s. That the Middle East has oil, but China has rare earths. It's a great line, and you'll see it in almost every article written about this subject. But it's worth being honest about the history here. Researchers who've gone back through the archives, including geographer Julie Klinger at the University of Delaware, have found that Deng's remark wasn't really about a master plan to corner a strategic market. It was made in a completely different context, and only got reinterpreted as prophetic decades later, after the fact, once the dominance was already real. The industrial outcome was genuine. The idea that it was the product of one man's foresight in a single speech is closer to convenient mythology. What actually happened was slower and less cinematic than that. Sustained state investment, tolerance for environmental costs the West was no longer willing to bear, and a Western industry that quietly walked away from a business it assumed it didn't need to fight for. By the time anyone in Washington noticed what had happened, the expertise, the equipment, and the workforce needed to do this kind of refining had migrated almost entirely to China. And once that expertise leaves, it turns out to be extraordinarily hard and slow to rebuild, a fact that will matter a great deal later in this story. The first real test of what this dominance actually meant for the rest of the world came in the fall of 2010. That September, a Chinese fishing trawler collided with two Japanese Coast Guard vessels near a set of contested islands in the East China Sea. Japan arrested the trawler's captain. In the diplomatic standoff that followed, multiple Japanese companies reported that shipments of rare earths from China had abruptly stopped arriving. Prices spiked by as much as 500% over the following year. Japan, which imported close to 90% of its rare earths from China at the time, was thrown into a genuine industrial panic, especially in the auto sector, where these materials are essential for magnet production. Here's where I want to be careful, because this is a case where the popular version of the story has gotten ahead of the evidence. China's government never officially acknowledged imposing an embargo, and when researchers later went back through Japanese customs data port by port, several found the picture messier than the headlines suggested. Some studies found no uniform, verifiable drop in shipments that could be cleanly tied to the political dispute. Whether Beijing issued a deliberate top-down order, or whether Chinese customs agents simply slowed shipments on their own initiative during a period of heightened tension, is still genuinely disputed among specialists who've studied the primary trade data. What's not disputed is the effect. The incident, real embargo or not, permanently changed how every government watching from the outside understood the risk. Japan spent the following decade funding rare earth ventures in Australia and Vietnam specifically, so it would never again be this exposed to a single supplier. The lesson landed, whether or not the mechanism behind it was exactly what people assumed. Which brings us to today, and to why a company blacklist in June of 2026 is a much bigger story than it looked. Modern military hardware runs on these materials in quantities that are genuinely hard to picture. An F-35 fighter jet contains more than 900 pounds of rare earth elements. A Virginia-class submarine contains over 9,000 pounds. The magnets involved aren't a minor component. They're inside the flight control actuators, the radar systems, and the missile guidance packages that determine whether these systems function at all. In 2022, inspectors discovered a Chinese-made magnet had made its way into an F-35's engine in violation of procurement law, forcing a temporary halt in deliveries. It wasn't a security risk in that instance. It was, however, a clear signal of exactly how deep the dependency actually ran. Congress responded by writing a hard deadline into law. Starting in January of 2027, American defense contractors will be barred from using Chinese-origin rare earth materials in national security systems at all, with waivers treated as a last resort rather than routine practice. The problem is that the same magnets required to meet that deadline, specifically the heavy rare earths, dysprosium and terbium, which allow magnets to keep working at extreme temperatures, are the ones China's processing monopoly controls most completely. As of this year, America's own showcase rare earth mine, the reopened Mountain Pass, still produces essentially none of them. And through 2025 and into 2026, China made unmistakably clear that it understood exactly what leverage it was holding. In April of 2025, Beijing introduced licensing requirements on 7 categories of medium and heavy rare earths. That October, it went further, introducing an extraterritorial rule modeled directly on an American trade tool, requiring a Chinese export license for any product manufactured anywhere in the world if it contained even a trace amount of Chinese-origin rare earth material. That measure was paused after talks between Washington and Beijing, but the underlying licensing regime never went away. By this past May, American imports of controlled rare earth compounds from China had fallen to zero for the first time since the restrictions began. And on June 22nd, Beijing placed MP Materials and USA Rare Earth, the two companies most central to America's plan to escape this dependency in the first place, directly onto its control list. Look at the pattern across those 4 moves, and the logic becomes hard to miss. This wasn't a blunt, one-time cutoff. It was calibrated, sequential pressure, applied and eased and reapplied, aimed with increasing precision at the exact firms and materials where American vulnerability runs deepest. That's not the behavior of a country improvising. It's the behavior of a country that has run this playbook enough times to know precisely where the pressure points are. Now, I want to be fair to the other side of this story, because there's a real and serious effort underway to change this picture, and pretending otherwise would be a mistake. The United States government has moved with a level of urgency toward this problem that would have been unthinkable a decade ago. The Department of Defense took a 15% equity stake directly in MP Materials, an almost unheard of move for the Pentagon, and committed to purchasing the company's entire domestic magnet output for its first 3 years of production. It backed a loan worth over $700 million to expand metal processing capacity at another firm, Energy Fuels. It's funding a company called Phoenix Tailings to build out separation capacity outside the traditional mining industry entirely. And in February of 2026, Washington launched a $10 billion strategic reserve initiative, modeled explicitly on the Strategic Petroleum Reserve, designed to stockpile critical minerals against exactly this kind of disruption. Outside the United States, the most meaningful progress has actually happened in Malaysia. In May of 2025, the Australian company Lynas achieved something no company outside China had managed before: commercial-scale production of separated dysprosium oxide, one of the two heavy rare earths that matter most for defense-grade magnets, at its refinery in Kuantan. The Pentagon signed a supply agreement anchored to that facility's output in March of 2026. This is real, meaningful progress, and it deserves to be described honestly as such. But here is what that progress can't yet answer. The International Energy Agency's own analysis, published in April of 2026, estimates that even accounting for every currently planned project outside China, non-Chinese refining capacity will cover only about a quarter of global demand by 2035 and less than a fifth of magnet-making capacity. Lynas's new heavy rare earth production line in Malaysia has a ceiling of roughly 1,500 tons a year. China's total heavy rare earth processing capacity is measured in the tens of thousands of tons. The gap isn't a rounding error, it's structural, and it isn't closing on the timeline that the 2027 defense procurement deadline actually requires. So here's the honest state of the race. As of right now, Washington has committed real money, real policy attention, and real urgency to solving this problem, faster than almost anyone would have predicted 3 years ago. And it is still, by the clearest available estimates, years behind the deadline its own defense procurement law has set for itself. Both of those things are true at the same time, and neither one cancels the other out. Which brings us to the mechanism underneath all of this, the piece I think is actually worth carrying with you long after the specific numbers in this story have changed. The natural instinct, when you hear that one country controls a resource everyone else depends on, is to think about geology. Who has the deposits? Who has the reserves? Who got lucky with what's under their soil? That instinct is almost always wrong, and rare earths are maybe the cleanest example available of why. The power here was never about who owns the most ore in the ground. It was about who controls the single narrowest, hardest to replicate step in turning that ore into something usable. Call it the refining choke point. In almost any modern industrial supply chain, real leverage doesn't sit with whoever has the largest raw resource. It sits with whoever controls the one process step that everybody else depends on, and almost nobody else has bothered or been able to replicate. Once you see that pattern here, you start noticing it everywhere else too. It's the same underlying logic behind why controlling advanced semiconductor lithography machines matters more than controlling silicon itself, since silicon is nearly as abundant as sand, while the machines that turn it into a working chip are made by essentially one company on Earth. It's the same logic behind choke points in shipping lanes, in specialized pharmaceutical ingredients, in any industry where the raw material is common, but the expertise to refine it is not. The specific material changes, the structure of the leverage doesn't. Which leaves us with the actual question this story raises for the next few years, and I don't think it has a clean, comfortable answer yet. The United States has finally started treating this as the structural vulnerability it always was, rather than a passing trade dispute, and that shift in seriousness is real and worth acknowledging. But seriousness and speed are not the same thing. Refineries take years to permit, build, and qualify to military specification in a way that no amount of political urgency can simply compress. China spent 4 decades building the capability the West is now trying to replicate in 5 to 10 years, and Beijing has demonstrated methodically in 2025 and again in June of 2026 that it knows exactly where to press while that gap still exists. The question worth sitting with isn't whether the West can eventually close this gap. On the current trajectory, it probably can, eventually. The real question is whether eventually arrives before a moment when the gap actually gets tested, a crisis, a conflict, a decision point where the difference between having the material and not having it stops being a matter of policy timelines and starts being a matter of what the next generation of fighter jets, submarines, and missile systems can actually be built with. Because choke points, once you understand how they actually work, don't announce themselves in advance. They just quietly determine who gets to say yes and who has to wait.